Hello again, guys, and welcome to another episode of the Human Resource Machine with Cass on the Maizuma channel. So, let's do some more progress. 35, duplicate removal. You see, I didn't do much of an intro this time, really, but I just want to, I'm just excited to play the game. Sorry, guys, had your coffee. Okay, you're fired. Haha, just kidding. But I do have a note here for your other supervisor, from your other supervisor, probably. She's out sick today, but she says it's time to eliminate inefficiencies. And that's it. Okay, send everything from the inbox to the outbox unless you've seen the same value before. Discard any duplicates. Okay, so we output E and then A and B and then we don't output this guy. It means that we need to keep a memory here. So we're probably going to store those guys here, and every time we grab a new letter we will consult here, we will look up. Okay, I see at least two ways of doing this. One is to keep a variable telling us the size of the memory, because this memory is dynamic. As we go, we will find new things to put here, and this size will grow. And the other way is to ignore the size and use a string terminator, like put a 0 at the end. I think I'm gonna try to keep track of the size of the memory, because I think it's a more elegant solution. Yeah, we don't need the 0 terminated string and update this, so let's try this first, and if it's not efficient enough, then we will take care of things. Okay, let's start by calling this 0 as usual, and let's have a variable called mem, which will be the size of the memory, and let's also call this m the index of this thing. So we should start by resetting this variable like this. And this guy also should be yeah, let's do this, because I know. Let me. So this is going to copy to M, and this is going to copy to mem. The reason why I'm copying twice from 0 is because I picture that in the future we're going to have a loop where we will always reset M, but we will never reset mem, the size of the memory. So if we need, we will change this later. Okay. So grab a number and then do we need a condition to see if the size of the memory is 0? I know. We need the test variable here, and then copy to test. Now copy from mem and subtract m. I think we should subtract this and copy from this instead. So if we get a 0, it means that we have reached the end of the memory. Let's suppose we have 3 entries here, so 0, 1, 2. We have a 2 here, and we have reached the index equals 2. If we subtract, it means that we checked all the possibilities here, and we need to insert this into the memory and also output this. Otherwise, we would have probably already found. Yeah. Okay. Let me not get confused. Let me just try to do some code here. So, if it's 0, then we need to copy from the test thing and then we need to copy to the location pointed to by memory. So it starts with 0 and it will store something here. Then we can outbox this value. Then we can bump the size of the memory, and then we reset. So we go to this place that I mentioned before. So we reset M, but not memory, which is the size of the memory, and then grab another number and so on. So okay, if it's not 0, we bump this guy here and just jump here. Really? Oh, we also want this to be an index. And we grab the next location in the memories. Then, oh, we also need to check. Of course, we need to check. This condition is just to see if we are at the end of the memory. Okay. Let's do some labels here. So insert, because this means we need to insert something into the memory array. Okay, so if it's not time to insert this, we still need to copy from... Oh, this is not index. This is like this. Yeah, this was right. So here we need to copy from... Yes, now we need the indexed location, and then subtract the test value. And if we find that we already have this in the memory, we just grab another number. So we reset the counting and then grab another number from the inbox. Yeah. And if not, we bump M and then we jump to the same location here? No. We bump M and then, yeah, once again check if it's the end of the memory thing. Okay. I think this deserves a try. Let's do things. Okay, resetting everything. So E, M, and mem are the same. So we grab test, store in the memory, outbox it, then bump memory. Now copy from 0, reset M, which would be unnecessary in the at this time. Copy from test. Okay. Now we check. They are different. 1. Okay. They are the same. It's the end of the memory. So grab A, store at the next available location. Okay, so let's see how this is going to do when we find E again. Okay. So B is going to be output. And now we find E again. So reset. Okay, it just ignores everything and grab another letter. I think we are fine, guys. Okay, first try. Wow. Wow. We used 19 commands. Are we efficient? No, we're not very efficient as well. So maybe we can improve something here. And I'm back, guys, with a new solution. This time what I did here is a much simpler initialization. We basically placed a 0 here and we got rid of the variable here. because we use the last location pointed to by IMAX as the test variable as well. Uh, in effect, I'm not sure if we are using less memory. Not statically, but maybe dynamically we are using less memory. Because this forces the algorithm to start by inserting something. We just jump here and then grab something from the inbox, then reset I, and then we check if we are at the end of the array, which will be the case for the first letter here. So in this case we have this condition here, and we just insert something here, which is what we just grabbed, and output here. So the first interaction is a little bit easier with this, and all the other things basically stay the same. I basically changed the variable we had here, and now it's part of the array. So yeah, let's see how this works out. Okay, with this solution we basically reached the minimum amount of instructions, but it's less efficient. I tried another solution which was very similar to this, and we were able to optimize the speed a little bit, but not really. So it's not worth showing, so let's move on. Okay, Alphabetizer. Seems like a tough one. Please be advised, this optional hallway is for advanced employees only. Bzz, bzz. Yes, indeed. Goodbye. Click. Oh, those robot-like sounds have to do with the storyline behind the game. But as I didn't show you guys the cutscenes, you probably don't understand 100% what's going on here. Incoming message. You will receive 2 words. One is a decoy, a false lead, a red herring. The other is part of an important message. The inbox contains exactly 2 words. Determine which words comes first. Which word comes first. If you were to order them alphabetically, and send only that word to the outbox. Oh my, we have to sort those guys. Oh man, I don't know why we have a 10 here. So let's place a 0 here. Oh, this is horrible. Let's at least try. Yeah, I tried. And 10. Okay, not sure yet why we're going to use this 10, but we will ah, yeah, I know why. Okay, oh, we can move this. Can we? Okay, let's stop derping around. So let's first copy the 2 words here by let's have an index here. Yeah, I guess so. Okay, copy from, oops, 0, copy to I, then inbox, copy to address pointed to by I. If it's 0, we should skip, right? So jump if 0. Yeah, and then bump I, and then jump here. Okay, we grab something from here and copy to this location, and then bump I, so it's okay. We are going to basically have to do this loop twice. So yeah, we basically need to copy the instructions all over again. So copy from 0, and then copy to I, and then everything again, right? The only thing that will really change is this condition. So if we could compare, no, not this condition. Oh, I don't think this is going to change. But we will need a second condition. Like, we start I with 0, and then we would just need to to do something like this. See, guys, copy from 10 and then start all over again, the same code here. And when the inbox is 0, we jump. We need to compare then. Okay. So copy from. Oh. We need to remember if we started at I or if we started at. Oh, I mean 0 or if we started at 10. Yeah, I don't think this is a real optimization here, because we're going to make the code a lot more complicated just to copy 2 strings. I don't know if this is ideal. Copy from 10. We will need to have another variable here. Let's see. Let's just try this out. If this is not good, we will change this later. And then copy from oh, I'm just being so derpy today. Copy to T. Okay. And once again we copy to T, so we don't need to do this, we just need to do this. Okay, so we start with 0, copy to T, so T is going to be 0, then we copy to I as well. Okay, so we have those 2 guys here. Then do the loop. So this is copy the strings. Okay, so if we find the 0 terminated string, we just come here. We copy from 0, from 10, and then we subtract T, and if it's 0, we jump out of this loop. Otherwise, we copy from 10 again and jump back up there. Yeah, I think this is going to copy the thing. So here is where we start to compare the strings. So let's see if this will indeed copy the 2 strings, one here and another one there. Okay, it seems to be working. Okay, these strings are not 0 terminated, which is not ideal, because we don't know the end of the strings in this case. But it does copy the 2 strings with a quite small piece of code, not sure. Jump if 0. Oh, we can just do this, and then it will store the 0 as well, I guess. Yeah, I think so. Okay, we copied the first 0 and copied the second one. Okay, so let's work on the comparison thing. Oh, this is going to be complicated. Okay, comparison is goes like so. We copy. I think we're gonna need 2 variables anyways. Oh man. Yeah, I think we probably will. Okay, so copy from I and jump if 0. So it's the end of some string. So let's call it and I. Okay, then we subtract. Oh, but oh man, we need to copy again. We need to check if this is 0. This is going to be copy from. We need to reset T as well. Copy from T and also jump if 0 to and T. This is getting messy. That much I can tell you. And T. Okay. So now we need to do some actions here. Before, copy from 0, copy to I, copy from 10, copy to T. Okay. Okay, and this is should be indexed just like this. Okay. Okay, so we have an initialization here, and we have conditions that tell us when the strings end, because we don't know if both strings are going to be the same size. So if it's not the end of any of the strings, we will just have to sub this guy, because we just copied T, so we subtract I. Okay. And if we find a negative number, means that I is bigger, so we should copy from the second string, which is T. Okay. If I ends first, then it's going to be the smallest. So if I is bigger, then we jump to this end here. Is this jump if 0 should, this guy should go here, this guy should go here. Okay. Now if this is 0, oh my. We have to bump I, then bump T, and then jump back here. Oh, I mean here. Okay. Okay, so this holds if they are the same. So if the same letters, we keep looking for a difference. Otherwise, I think we just jump to this end here. Oh man. Okay. Okay, in the end we just copy the string, which is the smallest one, and output it here. So I'm going to set this as if I always contains the smallest string. So in this case we're going to copy from 0 and jump down here, and in this case, in this other case, we're going to copy copy from 10, and then we are going to copy to I, and then we need to do another loop to output everything. So copy from wherever this thing is pointing to, outbox. If it's 0, then it's the end. Otherwise, we need to bump I. Okay. Let me see. Out. Wow. Awesome handwriting. Okay. So we decide if the smallest string is indexed by I or T. uh, whatever. And this is really complicated, guys. Sorry by being so derpy, but this is not really easy. Then we start copying from this location. If we find a 0, because it's a 0 terminated string, then we are out of this loop. Otherwise, we outbox, bump I, and continue copying from it. So we know that the first part of the algorithm, the copy, is going to work. At least I guess so. Okay, so let's see. Okay, it's resetting. Those are the same. So I reset again? Am I crazy? I don't know what I'm doing. I'm not bumping T. What am I doing? I'm outputting already. Okay. Oh, guys, I think maybe should. Okay. I should have stepped back, but it's okay. Let's just do it manually. Okay, so we reset it properly, and the conditions are probably wrong here. Okay. Copy from I. If it's 0, then this is the smallest string. We copy from... Yeah, this is indexed, so this is correct, I think. So copy from 0 and jump down here. Okay, but this is not 0. So we copy from T, we subtract wherever I is pointing to, and if it's negative, I is bigger, so we should copy the second string, so from T, and this ends the algorithm. Oh, this is inverted. Oh man, is it? Yes, it is. If it's 0, we need to bump I, bump T, and then once again copy from I, copy from 0, and then if it's not negative, not 0, it's positive, then okay, we just inverted one instructions. Okay, you, they're the same. So just bump both. Okay, now we're bumping both. So they are the same. So this case is fine. No. Okay. It maybe worked. Oh my. Oh my. Is this working? 37! Oh, it's not super efficient. Wow! Wow, I can't believe it. We did it, guys. We did it first try. I just inverted one instruction, of course, but I was thinking right. Oh man, this is awesome. This was difficult. Honestly, I can tell you guys. Okay, awesome. Unfortunately, guys, we are out of time for this episode, but I think that those challenges were pretty cool. And we are almost at the end of our journey here. So, wow, I'm really happy, guys, and I hope you are too. And if you are, don't forget to leave a like or a comment. And see you guys next time. Bye-bye.